So you want to convert a key code into a keysym without the help of XKB? Well, you're in for a world of hurt. A key code represents a physical or logical key. Key codes lie in the inclusive range of 8 to 255. A key code value carries no intrinsic information, although server implementers may attempt to encode geometry, for example matrix information, in some fashion so that it can be interpreted in a server-dependent fashion. The mapping between keys and key codes cannot be changed. A keysym is an encoding of a symbol on the cap of a key. The set of defined keysyms includes the ISO Latin character sets 1 to 4, katakana, Arabic, Cyrillic, Greek, Technical Special, Publishing APL, Hebrew, Thai, Korean, and a miscellany of keys found on keyboards, return, help, tab, and so on. To the extent possible, these sets are derived from international standards. In areas where no standards exist, some of these sets are derived from Digital Equipment Corporation standards. The list of defined symbols can be found in x11/keysym-def.h. Unfortunately, some CPU processors have limits on the number of defined symbols. If you must use keysyms not in the Latin 1 to 4, Greek, and miscellaneous classes, you may have to define a symbol for those sets. Most applications usually only include x11/keysym.h, which defines symbols for ISO Latin 1 to 4, Greek, and miscellaneous. A list of keysyms is associated with each key code. The list is intended to convey the set of symbols on the corresponding key. If the list ignoring the trailing no symbol entries is a single keysym k, then the list is treated as if it were the list k no symbol k no symbol. If the list ignoring trailing no symbol entries is a pair of keysyms k1 k2, then the list is treated as if it were the list k1 k2 k1 k2. If the list ignoring trailing no symbol entries is a triple of keysyms k1 k2 k3, then the list is treated as if it were the list k1 k2 k3 no symbol. When an explicit void element is desired in the list, the value void symbol can be used. The first four elements of the list are split into two groups of keysyms. Group 1 contains the first and second keysyms. Group 2 contains the third and fourth keysyms. Within each group, the second element of the group is no symbol. Then the group should be treated as if the second element were the same as the first element, except when the first element is an alphabetic keysym k for which both lowercase and uppercase forms are defined. In that case, the group should be treated as if the first element were the lowercase form of k and the second element were the uppercase form of k. The standard rules for obtaining a keysym from a key press event make use of only the group 1 and group 2 keysyms. No interpretation of the other keysyms in the list is given. Which group to use is determined by the modifier state. Switching between groups is controlled by the keysym named mode switch by attaching that keysym to some key code and attaching that key code to any one of the modifiers of mod 1 through mod 5. This modifier is called the group modifier. For any key code, group 1 is used when the group modifier is off and group 2 is used when the group modifier is on. The lock modifier is interpreted as caps lock when the keysym named xk_caps_lock is attached to some key code and that key code is attached to the lock modifier. The lock modifier is interpreted as shift lock when the keysym named xk_shift_lock is attached to some key code and that key code is attached to the lock modifier. If the lock modifier could be interpreted as both caps lock and shift lock, the caps lock interpretation is used. The operation of keypad keys is controlled by the keysym named xk_num_lock by attaching that keysym to some key code, attaching that key code to any one of the modifiers mod 1 through mod 5. This modifier is called the numlock modifier. The standard keysyms with the prefix xk_kp_ in their name are called keypad keysyms. These are keysyms with numeric value in the hexadecimal range 0xFF80 to 0xFFBD inclusive. In addition, vendor-specific keysyms in the hexadecimal range 0x11000000 to 0x1100FFFF are also keypad keysyms. Within a group, the choice of keysyms is determined by applying the first rule that is satisfied from the following list. Rule 1, the numlock modifier is on, and the second keysym is a keypad keysym. In this case, if the shift modifier is on or the lock modifier is on and is interpreted as shift lock, then the first keysym is used, otherwise the second keysym is used. Rule 2, the shift and lock modifiers are both off. In this case, the first keysym is used. Rule 3, the shift modifier is off and the lock modifier is on and is interpreted as caps lock. In this case, the first keysym is used, but if that keysym is lowercase alphabetic, then the corresponding uppercase keysym is used instead. Rule 4, the shift modifier is on, the lock modifier is on, and is interpreted as caps lock. In this case, the second keysym is used, but if that keysym is lowercase alphabetic, then the corresponding uppercase keysym is used instead. Rule 5, the shift modifier is on or the lock modifier is on and is interpreted as shift lock or both. In this case, the second keysym is used.